Back in the 1960s, Coltri began manufacturing small, high-pressure compressors to refill scuba tanks. The first compressor to come out of the Coltri workshop was the MCH-6. Developed from a pumping unit used on military aircraft compressors, it was the foundation on which Coltri compressors would build its future success. The MCH-6 is a portable, high-pressure compressor used to refill scuba tanks, other breathing system tanks, compressed air guns, and paintball guns. It draws in ambient air and, after a pumping and filtration cycle, delivers breathable air at pressures of up to 300 bar. The MCH-6 production process begins in the technical office, where the various components are designed and developed using 3D CAD systems. Some components are printed in a 3D resin printer for test purposes during assembly. Cast iron or aluminium parts are manufactured in the foundry department. For example, the cylinder block is made of aluminium alloy. First, the cylinder block core is made in a press, with silica and resin being injected into a hot mold. The worker inserts the core inside a shell mold. Aluminium bars are melted at high temperature in a crucible. A robot then picks a set amount of aluminium from the crucible and pours it into the mold. A few minutes later, the block solidifies and is extracted from the mold. After it has cooled, the sand core and any foundry residues are removed. Next, the cylinder block is X-rayed to check for pores, cracks, or any other flaws. Other compressor components, such as connecting rods, cylinder heads, and cylinders, are made the same way. On arrival at Coltri, foundry-made parts and raw materials are sorted. Here, beginning with technical drawings, a specialized worker develops CNC machine programs using software to control each stage of the process. Individual components are machined with lathes, milling machines, numerical control centers, or robots. A worker then checks them and certifies they have been properly machined. Some components undergo further finishing processes, such as lapping. Once machining has been completed, the components are washed in an ultrasound bath to remove any impurities. To ensure production processes are flawless, sample components are checked using precision instruments and CMM coordinate measuring machines to certify compliance with machining tolerances. Once all machining has been completed, the pre-assembled units are put together. Third-party components are picked from 3 automatic vertical warehouses and taken to the assembly department, where a worker assembles the individual parts. Here, a worker constructs a filter body by inserting plugs with O-rings and fittings. Next, the pumping unit is assembled. The second stage connecting rod is fitted on the gooseneck, which is equipped with a ball bearing. The resulting unit is then assembled on the cylinder block. A flange with an oil seal and a pulley are then fitted. The second stage piston, complete with piston rings, is inserted in the cylinder and secured to the connecting rod with a pin. Gaskets and reed valve are inserted and everything is bolted to the cylinder block. Assembly of the first stage comes next. The connecting rod is inserted in the gooseneck. Then the first stage piston, complete with piston rings, is inserted in the cylinder and secured to the connecting rod with a pin. Once again, gaskets and reed valve are inserted on the cylinder head and the entire assembly is bolted onto the cylinder block. A stainless steel coil is installed between the first and second stages to cool the compressed air. At this point, the third stage piston, complete with piston rings, is inserted in the cylinder and fixed to the connecting rod by a pin. The spring, gaskets and plate valve are inserted on the cylinder head and the resulting assembly is bolted to the cylinder block. A safety valve is fitted on the head to release excess pressure in the event of a malfunction. Another cooling coil is installed between the second and third stages and secured to the second stage cylinder head to prevent vibration. The fourth high-pressure stage piston is installed on the connecting rod and secured with a pin. Connecting rod and piston are then inserted on the gooseneck. The cylinder, complete with spring, plate valve, cylinder head and manifold, is then fitted onto the piston and secured to the cylinder block with bolts. Afterwards, the cooling coil between the third and fourth stages is installed and secured to the third stage cylinder head. The worker rotates the compressor to check all the installed stages are working properly. He inserts the dipstick and fills the cylinder block with oil. Next, a flange, complete with oil gasket and O-ring, is fitted to seal the cylinder block. The MCH-6 pumping unit is now ready for initial testing in a soundproofed chamber where it will run for 2 hours to check it is working properly. Once tested, it is transferred to the painting department. All pumping units are washed with a degreasing agent. Once dry, they are placed in a booth and coated with a water-based paint. They are then heat dried. Now the compressor can be assembled. A stainless steel pipe connecting the pumping unit to the condensate separator is fitted. The pumping unit is mounted in a steel frame which has been coated with thermo-hardening powder paint. The cooling fan is attached and a protective grating is assembled and secured with screws. Next, the purifier body is fitted, together with a condensate separator with pressure gauge. They are then connected to the pressure circuit piping. An electric motor or internal combustion engine is mounted on the frame. The worker then inserts the crankshaft and transmission belt, checking for correct alignment. The pulley is fitted and shielded with a mesh, which is secured to the frame. The safety valve is then installed on the condensate separator and an intake filter, complete with filtration cartridge, is fitted. At this point, the compressor is tested again. The refill hose is connected up and components are checked to ensure seals are tight and all parts are working properly. After final testing, safety labels are applied. The compressor is then moved to the packaging department. Here, each compressor is protected with bubble wrap, then placed in a cardboard box together with all the supplied components. Liquid polyurethane foam is poured into the bags to protect the compressors during transport. The box is then stapled and taped. Lastly, the completed packages leave the company to be shipped all over the world.